Start by understanding what a stack is. In computer science, a stack is a linear data structure that follows a particular order in which operations are performed. The order is commonly known as LIFO, which stands for last in, first out. This means the last element added to the stack will be the first one to be removed. Imagine a stack of plates. You add new plates to the top and also remove plates from the top. Stacks are used in many programming scenarios and are fundamental to understanding how data can be managed efficiently. Now that we know what a stack is, let's explore how it works in practice. Stacks support several basic operations. The most common are push and pop. The push operation adds an element to the top of the stack, while the pop operation removes the top element. There's also the peek operation, which allows you to look at the top element without removing it. These operations make stacks very useful for tasks where you need to reverse items or keep track of recent actions. For example, when you press the back button in a web browser, it uses a stack to remember your previous pages. Understanding these operations is key to using stacks effectively in programming. Any data structure, stacks have their strengths and weaknesses. One major advantage is simplicity. Stacks are easy to implement and use. They are also efficient for managing function calls and undo operations. However, stacks have limitations. Since you can only access the top element, retrieving other elements is not straightforward. Also, if the stack grows too large, it can lead to overflow errors. Understanding both the advantages and disadvantages helps you decide when a stack is the right tool for your programming needs. Next, let's see where stacks are commonly used. Stacks are widely used in computer science and everyday applications. They are essential for managing function calls in programming languages, where each call is pushed onto the stack and popped off when completed. Stacks are also used in algorithms for reviewing data, checking balanced parentheses in code, and implementing undo features in software. Even web browsers use stacks to keep track of your navigation history. By understanding stacks and their applications, you can write more efficient and organized code. This makes stacks a fundamental concept for every programmer to master.